Let's talk a little bit about exponents. We're going to call this Exponents Part 1. We'll talk about some of the more basic ideas in Part 1. Then in Part 2, we'll take it a little bit further. Suppose you have a bunch of numbers multiplied together, same number, okay? You've got, in this case, we've got 2 times 2 times 2 times 2 times 2. Exponentially, you would call this 2, let me get a pen going here, 2 to the 5th power. 2 to the 5th power. Now, understand that 2 to the 5th power does not mean 10. It's a whole different thing than 2 times 5 is 10. Let's make some space and see how we can work this out. Let me rewrite this up here. 2 to the 5th power equals all of this. So let's see what 2 to the 5th power actually equals. We have 2 times 2, which is 4. Then we have 4 times 2, which is 8. 8 times 2 gives us 16. 16 times 2 gives us 32. So 2 to the 5th power equals 32. Let's take it the other way around now. 4 to the 3rd power. Now let me backtrack a little bit and let's do a little bit of a little definitions, couple of definitions. Okay, first of all, this guy right here, the big guy, he's called the base. It's all about that base. Well, not that base, but this base. This guy right here is called the exponent. Okay? Again, when you have 4 to the 3rd power, it does not equal 12. No. Get that out of your mind now. No. Wrong, wrong, wrong. Let's take a long trip. Let's break this out a little bit and see exactly what this means. Okay, so 4 to the 3rd power means this. You take the base, and you write it this many times. So I'm going to write 4 3 times. 4, 4, 4. Then you're going to hang a multiply sign in between each of the numbers. So now we've got 4 times 4 times 4. See? So 4 times 4 gives us 16. And 16 times 4 gives us something that I'm not sure about in my head. Let's do it the long way. 6 times 4 is 24. That's what I thought, 64. I wasn't sure though. So 4 to the 3rd power equals 64. Sometimes you'll have exponents where the base is negative. In this case, it's negative 2 to the 5th power. So let's see how that looks. Let's get rid of this little line. We don't need it. 2 to the 5th power looks like this. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Sometimes in algebra, when people see a whole bunch of negative signs, it kind of throws them off a little bit. So let's just take care of that right now. Oh my goodness, my alarm is going off. So let's just make let's just note some definitions that'll help us not get hung up by all of these negative signs, okay? So let's do this. If there are an even number of negative signs, the answer will be positive. Okay? So let me pick a different color here. Let's use orange. Orangey, glad that you're watching this video. Okay, anyway. Yeah, enough of that nonsense. Now, let's just put a plus over here. Nope, sorry, not a plus. My bad. Let's put odd up here. That's what I meant to say. And let's put a minus right here. So if you follow the color code, we have two rules. Rule 1 says, if there are an even number of negative signs, the answer will be positive. The other rule says, if there are an odd number of negative signs, the answer will be negative. So let's count them up. We've got 1, 2, 3, 4, 5. We have five negative signs. 5 happens to be an odd number, so the answer will be negative. So let's just make a little answer box here and put a negative. Okay, now I can just deal with the numbers without thinking about the signs. I don't care about them anymore because I already know the answer is going to be negative. Now I can just put the signs out of my mind and just focus on the math. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Do I care about the signs? Nope. Nope, 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 nope. I'm just going to plug the answer in here. Because I know it's a negative already. I mean, I do care about the signs. I shouldn't say I don't care about the signs. The thing is, we took care of the signs from the get-go, and so we don't have to worry about it anymore. Once we establish that the answer is either positive or negative, we don't worry about the signs in our calculating the math. We just do the math. Isn't that easy? Pretty colors, and such fun, too. As we continue in this thing called algebra, sometimes we're going to be tasked with carrying out certain operations. In this case, multiplication. We're multiplying two exponents together. But I want to show you something. Note that the bases are the same. Believe it or not, that makes our job a whole lot easier. Because in the answer, the base is going to remain 4. Okay? Now, here's the hard part. Are you ready? This is very difficult, so hang on. When you're multiplying exponents, all you do is add the exponents together. So this is 4 to the 3rd power. This is 4 to the 5th power. You add the exponents together. 3 plus 5 is 8. And you end up with 4 to the 8th power. Y'all still with me? I know, that was a brain buster, that was. So the base remains the same as long as the bases are identical. The answer is the base and the sum of the two exponents. I was teasing earlier. That was really pretty easy, wasn't it? You know it was. Okay, so let's make a rule, or let's note the rule. We're not making a rule. The rules already existed. When multiplying exponents, I'm going to abbreviate exponents with the same base we'll say the same base number, the answer will be the base and the sum. That's a U. Just take my word for it. Sum of the exponents. And bearing in mind, sum means addition, right? S-U-M, addition. Sum is the addition, the answer to an addition problem. You know, I only meant to erase a little bit, and I almost erased the whole thing. Will be the base and the sum. Okay, I think I've reconstructed it. When multiplying exponents with the same base number, okay, we got 4's here, the answer will be the base, 4, and the sum of the exponents, 3 plus 5. Okay? So 4 to the third power times 4 to the fifth power equals 4 to the eighth power. So based on that information, I bet you can't guess what's going to happen here since we're dividing. If you said subtract the exponents, you are correct. So just as before where we added the exponents when the bases were identical, in this case the bases are identical, so the answer is 6 to the, we're going to subtract now, 5 minus 3 equals 2. 6 to the second power. I'm not going to write out the rule because it's pretty much identical to this rule, except we're subtracting instead of adding. Here's a rule that's very helpful on some problems because it makes it very easy to solve them. N represents any number you like. Any number you like. Any number in the world. N to the 0 power. Any number in the world to the 0 power. Any number to the 0 power always equals 1. 6 to the 0 power equals 1. 19 to the 0 power equals 1. 6,397,423 to the 0 power equals 1. Any number to the 0 power equals 1. Easy peasy, lemon squeezy. Okay, that will conclude part 1 of exponents. Stay tuned for part 2. Exponents part 2, we'll take it a half a step further and explore some fun stuff there.